Hello and welcome to my channel. So, Happy New Year, everybody. So I have stopped doing the video for like more than 1 month now. The main reason is I started a new job in the end of November. So I don't have much time to do the video lately. But I'm going to maybe if I find the time to do more in the future. So thank you for your support. Um, so today let's look back at the last weekend's contest, question 2. Um, it's a weekly contest 275. So firstly, actually here, this is my result. I'm not able to solve this question during the contest, but I did solve that just 3 minutes after the contest was ended. So yeah, I will. The main reason is I spend a lot of time on Q3, and then I don't have much time on Q2. So also I didn't come up with the easy solution. So I was thinking in a complex way. So okay, so now let's look at this question. So the question is 2134 minimum swaps to group all ones together. 2. A swap is defined as taking two distinct positions in an array and swapping the values in them. A circular array is defined as an array where we consider the first element and the last element to be adjacent. So yeah, so this is one of the points circular array. Then given a binary circular array norms return the minimum number of swaps required to group all ones present in the array together at any location. So, for example, we can see the example 1. So for this array, we only need one swap to gather them together. So we can either swap this one with this 0, then we will get right. We will after swap we will get this. So all the ones are together. So this question, this first example, we didn't see the problem with the circular array. So let's look at the third example. So the third example, actually, we don't need to do the swap because the first and the second is already connected with the last one because it's a circular array. So it's 0 swaps. So how do we deal with the circular array? Actually, there's an easy way to deal with that. Is we can actually connect the two arrays together. So for example, for this one, we can connect again the same array. So we have a new array which is just double the length of the first array. So this is one of the way to deal with that. So we can still simplify, but this one will help you to think. So firstly, circular to deal with a circular array, concatenate two arrays. So the second problem is how many swaps, how many minimum swaps do we need to gather all the ones together. So this is a little difficult to think forward, because we want to think how do we swap, and then it's really difficult to think that way. But we can think backward. So this is a think backward. So firstly, we define how the result is like. because all the not ones are together, so we for this array we will have the result can only be like um, 3 ones, because there is only 3 ones in the original array. So this 3 ones can starting at any position. It can start at 0, right? It can start at 0, but it can also start at 1 or it start at 2. So start at 3, and so if it's a double length array, then we can do until it start at this index. So there is only this much possibility. So what we can do is we just enumerate all the possibility, and then we compare with the array. See, like how many zeros are in this 3 location. The number of zeros actually is the number of swaps you need to do. So for example, if you are this 111 is here, then you only need to do 1 swap, right? Because there is only 1 hole in the, but here you need to do 2 swap. Here you also need to do 2 swap. Here you don't need 1 swap. Here actually you do 0 swap. So you found the minimum value. So actually we are actually using a sliding window approach to find the minimum number of swaps. So we just need to keep a variable and compare. Yeah, so this is like the think process, and I think the time complexity will be O(n). The space complexity here, because we are using like a helping array, so we have space complexity is also O(n), but it can reduce to O(1). Because actually we will firstly implement the O(n) solution, space O(n) and time O(n). So let's start working on this. So firstly, we need to find the count of the ones, right? So the count of ones, we actually, there's no way to find it other than iterating the array. So we have to iterating the entire array. So let's yeah. So if actually there's another way to do that is we just add, because either 0 or 1, right? The value is either 0 or 1. Also, it's lower than 10 to the power 5. So it's want to cause overflow. So yeah, then now we have the number of ones. Next is we need to, also I said we want to create another array called maybe nums2, and this is the 2 times of nums1. So nums2 I use nums1 I, and nums2 I plus n will also be nums I, right? So yeah, after this, the nums2 is constructed. Then the next step is we can start iterating. So we have a sliding window. So we can firstly getting the first case, the number of ones in the first k. So yeah, so we can initialize the window. So the numbers of count of number zeros. Yeah, we can call it zeros. So zeros, if nums 2 I is 0, then we add a 0. Yeah, so this zeros will be the yeah, we also want to have another one is a minimum swap or like answers. So the answers maximum is we can put it n, right? So we just need to also we can actually another way is we can assign zeros to answers. So the minimum, so this is initial value of answers. So now we start doing the sliding window. So so we can start I is 1 and I plus zeros, not zeros, actually ones, minus smaller than 2 times n. So this will this is all the possibility of the window. So yeah, actually we can start up with 0 and maybe until 2 times n minus 1. Yeah. So here, if the number size is 0, then we need to reduce zeros by 1. And if nums I plus 1s is yeah, actually I think maybe this one is smaller than 2 times n. So if that one is 0, then we need to add zeros. So then we actually we are doing the sliding window. So then we also need to like find the minimum of compare it with answers. So then in the end, it's the answers is what we need. So let's try if this is working. There might be some compiling issues, and yeah. So okay. So it should be I plus 1s minus. Yeah, it should be. It might should be this. Oh, index 7 out of the bounds for length 7. Oh, yeah. So actually, we are talking about the nums 2. So this is, yeah, sorry about it. So it's actually be nums 2. We are doing the sliding window on nums 2, not the nums 1. So, yeah, so this is a correct. The second question, the second example, let's try another two examples. So both are correct. Okay, so I think this will pass. pass the online judge. It should be, but maybe there is a yeah. Okay, then we can still, as I said, we can still uh, optimize. So actually, we can remove the norms too. We actually don't need the norms too. So we just do norms one norms, and then here we can actually we just need to do the like we just need to do a mod on n. So this will actually only use the original array. We don't need an extra array. Yeah. So the reason is we actually do like the index mod n. So then we actually when we reach to the end of the norms, then we go to the beginning by this way. But as I mentioned that the norms too actually help you think of how to solve this question. So I actually didn't come up until the end of the contest. That's why I didn't. I was not able to solve that. So I only solved the two questions in this contest. So let's submit this. Yeah. Oh, okay. Actually, it's still even a little slower than the previous approach. Anyway, it might be because the overhead of this mod or something. Yeah. So anyway, okay. Thanks. Thanks for your support. So if you like the video, please subscribe and or comment. Let me know if you have any questions. Thank you for watching. See you next time.